Good morning. Okie dokie. Okay, we'll get started in just a couple more minutes. Looks like we're still waiting a few more people, but yeah, we'll start maybe once there's just a couple more folks. Because right now it's just 3. Oh, good morning. 4 people. Yeah, so we'll just wait a couple more minutes. I mean, it does appear as though most of us are watching the video after the fact. Just looking at yesterday's video, we got about 20 views. I know that it sounds kind of vain to talk about like your own views, but I'm just trying to consider how many people are watching the videos. It is important in terms of attendance. So yeah, I mean, if it's just a few of us who are watching it live, I suppose that's okay. But yeah, it looks like pretty much almost everyone is watching the videos at least after the fact. Certainly, you know, everyone's handing in their assignments and everything, so I don't have any huge concerns in that respect. I think I'd also just like to point out, please do fill out the exit slips. I know that you know, sometimes you're watching it like maybe even a few days after the class aired. That's fine. Just let me know that you watched the video. It really is important that I'm reporting numbers that are as accurate as possible. So yeah, that's what we're gonna do today. Is well, I guess I didn't say what we're gonna do today. Good question. What are we going to do today? Well, we're going to continue on with trigonometry. I'm a little embarrassed by something that is on the screen right now. I wonder if anyone can notice any kind of mistake that I had on the screen. It's not necessarily like a mathematical mistake, but I think any mathematician who takes themselves even remotely seriously would be a little bit embarrassed by this mistake. I spelled tangent wrong yesterday. I'm really embarrassed by that. That is like totally not how you spell tangent. It's with a G, tangent, like gentleman. Yeah, oops, whatever. I guess it's not that big a deal, but I just saw that today. I was like, what? Tangent with a J? No, it's tangent with a G. I'm your math teacher. I should really be... Aha, look at that. Looks like someone figured it out. Maybe that was after the fact. Anyway, yeah, so we're going to continue on with trigonometry. This class, I'm hoping will be a little more interactive in that I'm going to give you some opportunities to try some of the questions yourself. And I'll say this, I've said it before, and I can't emphasize this enough. It is important that you try these. So I know if you're watching after the fact, it might be tempting just to hit that forward key on the keyboard to fast forward a little bit and just see me finish it. But it really is important that you try because at the very least, you should be able to look at the question and say, okay, what is this question asking? Like, what are the things that I need to do? And then start doing them. So if you don't already have a pencil in your hand and a piece of paper, I really, really encourage you to get one. And it is a little bit maybe every single person is already doing this, and I'm sort of preaching to the choir here. I can't see your faces. I don't actually know what you guys are doing. So I'm just trying to imagine that, like, if it was me, I would be tempted just to, oh yeah, it's like first thing in the morning, and kind of just let the teacher do all the work. But I really hope that you can find the energy to actually get out a piece of paper and a pencil and actually follow along and try these questions yourself. Because if you're not trying them yourself, then you're robbing yourself of the opportunity of practicing, right? Like with any sport, you need to actually practice it. If you've ever had to learn an instrument, you know that you have to practice. I can tell you firsthand, I have not practiced that thing in, well, actually I practiced about a month ago, but it was the first time in a couple of years before then, and I can tell you that it did not sound very nice. So some things you just need practice, and mathematics is no exception to that. So what I thought I'd do today is I would just throw a couple of questions at you and see what sticks. So okay, let me get out purple. Okay, we'll try this question here. So this is kind of a warm-up question, and I purposely sort of hid last class's slides. If you already have them in front of you, then that gives yourself a leg up. So if you've been taking notes, then having that little diagram is going to be really helpful. But if not, then I suppose you could scroll back in the video. But I'm hoping at the very least we can memorize that at some point soon. So so yeah, what am I asking today? So I'm going to identify all quadrants for the angles satisfying the following conditions. Okay, so I'll sort of paraphrase that. So for which quadrants is the following true? Okay, so question A, I'm going to say that sine of alpha, so alpha is, you know, just another Greek letter that we can use as a variable. And let's see. Okay, yeah, so sine of alpha is, sorry, I just, the question here is kind of phrased weird. I'm having to reinvent it on the fly. I looked at it ahead of time, it looked fine, but now that I see it, it's a little bit funny. And then cos of alpha is greater than zero. Okay, so which quadrant is the following true? I should say quadrant. There's only one quadrant where this is true. And I should say and. So which is it? So which is it? Is it quadrant 1, 2, 3, or 4, where sine of alpha is less than 0 and cos of alpha is less than 0, or greater than 0 rather, is greater than 0. So I'll give you just a few seconds. I don't think we need too much time for this one. How about 10 seconds? So 10 seconds, go. All right. Okay, so let's see here. So I'm just going to draw a quick little, Cartesian plane here, drawing all 4 quadrants. There we go. Remember, this is quadrant 1, 2, 3, and 4. Okay, so we're looking for values where sine is less than 0. So remember, sine refers to the how far up and down you are in the positive, or sorry, in the negative direction. That would be these 2 quadrants. And when cos is greater than 0, remember cos refers to our x coordinate of that terminal side. Oopsies, I didn't want my eraser, I want the pencil. So here we go. So those are the 2 quadrants where that's true. So the only way that this is possible is when we have the 4th quadrant. So this is true for quadrant 4. Okay, quadrant 4, that's true. Okay. Okay, so B, so the second one, I want tan of beta to be less than 0, and I want cos of theta to be less than 0. Okay, so when is both cos and tan less than 0? And again, Well, maybe this one will give you a little more time. Oopsies, what's going on here? I'll give you 15 seconds for this one, okay? So think about that. When is both tan of beta less than 0? Oh, and sorry, cos of beta. We have to have the same. That's what was wrong with the question. That's why I was confused. The same angle. Okay. Well, the 15 seconds already went, but yeah. So I guess the problem with the question that I was sort of, maybe you noticed I kind of had to pause after reading question A, is that there's a different angle, and it's important that we're talking about the same angle, because if we're talking about two angles, well, they could be in different quadrants, right? So we do have to talk about the same angle here. So if cos of if tan of beta is less than 0, I should also point out that there's another and statement here, and cos of beta is less than 0. Well, let's think about which quadrants this could be true. Well, let's list all the ones where tan of beta is less than 0. Remember that we have this rule cast, okay? So if we're looking for the ones where tan is negative, well, let me circle those. I'll circle those in blue. So here's the blue represents where tan of beta is less than 0. Remember, A means all of them are positive. S means that only sign is positive, so everything else is negative. The T means tan is positive, and C means only cosine is positive. So it would be these two right here. And where else could cosine of beta be less than 0? Well, I'll do that in orange. So so cosine of beta is less than 0, where it's not going to be A, it'll be at S and T, right? Because that is where either only sine is positive, everything else is negative, or only tan is positive, everything else is negative, okay? Okie dokie. Okay, next question here. I'm going to throw this one at you. By the way, if any of these seem a little bit confusing, or if you didn't quite catch that, let me know in the chat, and I'll see what I can do to make it a little more clear. Okay, so I really like these types of questions. This is where this stuff starts to get a little more interesting. We have to do a little bit of problem solving. So this is the kind of question that'll probably give you about a minute, 2 minutes to mull over. So let's try if cosine of alpha is equal to -5/13 with alpha in quadrant 3. I should say Roman numeral 3. There we go. I want you to find, sine of alpha and tan of alpha. Okay, so if cosine of alpha is equal to -5/13 with alpha in quadrant 3, I want you to find sine of alpha and tan of alpha. Okay, so give you, I think, a minute and a half for this one. Give you 90 seconds. Okay, time's up, folks. Okay, let's see how we did. So I mean, these questions, they really work well when you make a diagram. So let's start off with a diagram. So here's my little Cartesian plane, and right off the hop, we're told something really important, that alpha is in quadrant 3. And in addition to that, cosine of alpha is -5/13. So let's just double check, make sure that that is even possible. I mean, obviously it is, but it is good to check these things. So let's write our cast rule here. So cast is right there. So the third quadrant, now remember that the cast and the actual naming of the quadrants don't actually necessarily line up. Right, here's 1, 2, 3, and 4. Okay, so let's just double check that that's possible. So if cosine of alpha is -5/13 and we're in the third quadrant, well, okay, here, let me change my color here. That seems to make sense because only tan is positive. Everything else is negative in that case. Okay, so let's start drawing a diagram. I'm going to get rid of the letters, but I'm going to keep my Cartesian plane because I still need it. So so alpha is going to be somewhere around here, right? And alpha is kind of doing this sort of thing, right? We're starting at the initial side right over here, and alpha goes all the way around, almost like 270 degrees. So a little bit over 180 degrees. So alpha, I think we call that a reflex angle when it's past 180 degrees. Okay, so alpha is equal to -5/13. Now, recall that we actually have these reference angles, right? So let's recall what that reference angle is going to do for us. So this is our reference angle here. So our reference angle is right here. I'm going to call it alpha prime. So alpha with a little apostrophe next to it. And this makes a right angle. And all of a sudden we have a right angle triangle. Okay, so the way cosine is calculated here is as if we are doing a right angle triangle using the reference angle as our subject angle. Okay, so what we're going to do is we're going to say, okay, well, cosine of alpha is equal to adjacent over hypotenuse. Right, adjacent over hypotenuse. So let's go ahead and calculate that. So in this case, we're told that this is equal to -5/13. So remember that this is just a ratio, but these numbers will work. So why don't we, like anything that we do, like if you want to think of your radius here, like this arm as being length 1, or this could be any length that you want. Like you could have this ratio, this cosine ratio, be true for any number of similar triangles. But the important thing to remember is that because they are just ratios of each other, the actual choice of one of the sides doesn't matter as long as everything else is proportional to that. So why don't we just say that the adjacent is equal to -5 and the hypotenuse is equal to 13. Okay, well, in that case we would have 13 over here as a hypotenuse. The adjacent side right over here would be -5. Here I should stick to orange, so right over here would be -5, which makes sense because it's going in the negative direction. So our positives and negatives work out. If they didn't quite work out, we could work with that. Pretty much as a rule, your hypotenuse should always be positive. Always be positive. As a rule, it doesn't really make sense to have a negative hypotenuse. But the other, because that kind of represents a length, but the other dimensions should correspond to whether or not you're going in the positive or negative direction on the Cartesian plane. Okay. So that's -5, that's that positive 13. Let's figure out what this opposite side is, right? And we could use the Pythagorean theorem for that, right? That's, you know, it's just a missing side of a right angle triangle. So remember that the Pythagorean theorem is that a squared plus b squared is equal to c squared. I really hope that that's something that's memorized by everybody. So we're looking for the opposite side, which is one of the legs. So why don't we call this side A, this side B, and this side C? So C is always going to be the hypotenuse. You don't get to choose. But the two legs, A and B, you totally get to decide which is which. So just because we're solving for A, sometimes I like to leave that for like the letter A because it's the first letter of the alphabet. So anyways, I'm going to solve for A here. So A is equal to the square root of C squared minus B squared, right? But we're really good at using radicals by now, so that's awesome. Okay, let's see here. Okay, so let's go ahead and calculate this. So what did I say? C squared was 13 squared, so A is equal to 13 squared minus, and then B is negative, but it's okay because we're squaring it. So it'll become positive. And we get, well, this would be the square root of 169 minus 25, right? And this is the square root of 144. Hey, look at that. That's equal to 12. Beautiful. So the opposite side over here, I'll just sort of erase this. This is now 12, okay? So that gives us a lot to work with. Okay, so let's carry on with this. So I've got now I've got all my sides of this triangle. So now I'm looking for sine of alpha and tan of alpha. Well, sine of alpha is going to be, well, that's opposite over hypotenuse. So that's going to be, oh, by the way, this should be, you might notice this should be negative 12 now. Even though there's nothing about the Pythagorean theorem that tells us that this is negative, the Pythagorean theorem is helping us solve for the length of this, right? It's not going to tell us if it's positive or negative. But just by looking at it, because it's going down and this is like in exactly the y-axis, right? So this represents a value of negative 12. So sine of alpha is the opposite over hypotenuse, so this should be negative 12 over 13. And the tan of alpha is equal to, well, opposite over adjacent, so we've got negative 5 over negative 12, or in other words, 5 over 12. And maybe now you can start to see why, if both the sine and the cosine are negative, then that means that the tangent of that same angle must be positive. Okay? Okay, I hope that this is going okay. I know that we did a bit of a jump from lots and lots and lots of theory, just theory, and then all of a sudden, boom, a lot of examples. This one in particular involved a little bit of problem solving, but that's okay. I'm going to give you another one very similar to this. Okay, and this one I'm just going to give you the solution. I'm not going to work it out, okay? I just want you to do this one, okay? So just in the interest of time, I don't want to spend 10 minutes explaining each question. You try it, and then I'll let you know whether or not you did it correctly. Okay, so I want you to calculate tan of theta. If sine of theta is equal to 1/3, if sine of theta is equal to 1/3 and theta is in, quadrant 2. Okay, so I would start off by drawing a little diagram, right? 1, 2, 3, 4. Try to get a sense of which quadrant we're in, which values are positive or negative or what have you. Right? You've got C, A, S, T, that kind of thing. So start there. This one I'm gonna give you 3 minutes for this one, and we'll see how that goes. So 3 minutes starting now. You are correct. Sorry, in the chat someone pointed out this should be 12 over 5. Thank you. 12 over 5. My bad. Thank you very much. Opposite over adjacent. Yeah. Opposite over adjacent. Sorry about that. Okie dokie, we're done. So let's see here. So the gist of this one is, yeah, pretty much we just are going to make a right angle triangle based on the diagram that we have. So it should look something like this. And again, like I said, I'm not going to solve this one completely, but we'll have something like this. So we'll have 1/3, and then you would eventually find that that this value right over here is, what would that be? Negative, what is it? -2 times the square root of 2. So, let me make that look nice. And yeah, so that's pretty much what we're looking for. And then, so tan of theta is going to be, you know, opposite over adjacent. So opposite over adjacent. So it'd be 1/2 root 2. And that's pretty much it. So let's try a couple more. I'd like you to get a little more practice. Let's try. Yeah, let's try this one. Slightly different. Well, I mean, a little bit different, but not quite. So calculate. I want you to calculate sine of beta if tan of beta is equal to 2.135. 2.135 with beta in quadrant 3. Okay, so I want you to try that one out. The main thing that's different about this is that we don't have a fraction here, so you'll have to sort of improvise on that one. There's several ways of tackling that one, but I'll give you 2 minutes for that one, starting now. Okie dokes, let's try this one out. Okay, so what we're gonna do here is the main thing that makes this one a little bit different than the others is like I said, this is not a fraction, so we don't really get to choose like the ratio itself, right? We're not really given a ratio, but it is a rational number. So in a lot of ways, we can turn 2.135 into a ratio. So that could be like 2.135 over 1, right? That's, you know, frankly, that's the one I'm going to use. But if I wanted to, you know, make it a little bit different, I could have 2,135 over 100, right? That would over 1,000. Let me write that a little bit nicer. Over 1,000, right? That could certainly work as well. I could even reduce this fraction, so I know that both of these are divisible by 5 at the very least. So 2135 divided by 5 is 427, and that is not divisible by 3, and I'm not interested in reducing that. So it could be 427 over 200, right? These are all values that are equal to 2.135, right? So I'm going to use this first one. That's what I'm going to start off with. So yeah, 2.135 is the same thing as 2.135 over 1, right? These all have the same ratio, and that's really the take home here. Is like if you are going to say that you understand trigonometry, then you do have to understand that trigonometry deals with ratios, and we're talking about right angle triangles. And in right angle triangles, you can make similar triangles with the same ratio of sides, and that trigonometric ratio is going to remain constant no matter which triangle that you have. So if we had a triangle that, well, remember tan of beta is going to be opposite over adjacent. So if you had any triangle with these ratios of opposite or adjacent, or like opposite as the numerator and the adjacent as the denominator, so any of these would all be similar triangles. These are all similar, so all of the ratios are going to remain constant throughout. So that's the main take home from this. So let's go ahead and start graphing this. So here is my set of coordinates, and I've got tan of beta is equal to 2.135, and we're in quadrant 3. So that's 1, 2, 3. So we're down here like this, and that makes sense, right? Because we have the CAST. So here tan is positive, and we've got a positive value given to us. 2.135 is positive. So let's see here. Let me erase this stuff. We don't need it anymore. 2.135 over 1. So remember that this is our reference angle right here. So that's the angle we're going to sort of pretend is our right angle triangle. Even though tan in reality starts from here, or sorry, beta, not tan, but our angle beta starts from the initial side right over here and goes all the way around, but our reference angle is this smaller angle that I'm going over right now. So this is our reference angle. So using our reference angle to sort of map out our opposite and adjacent sides. So opposite would be 2.135, adjacent would be 1. That makes it nice and easy. And we're asked to find sine of b, or sorry, sine of beta. So remember, sine of beta is going to be, well, it will be opposite over hypotenuse. And we have the opposite side. The opposite side is 2.135. And what we're left with right now, well, that's what we have to solve. So it's 2.135 divided by something. So let's see if we can calculate that. So I'm going to sort of just copy out this right angle triangle here. And there we go. There's my right angle triangle, and right, it's the same angle there. Okay, so I've got 2.135, I've got 1, and I've got this one right over here that I'm looking for. Well, a squared plus b squared is c squared, right? So in other words, c, or the hypotenuse, I'll write hypotenuse, is equal to the square root of 1 squared plus 2.135 squared. And let me just use my handy dandy calculator for that. So 2.135 squared equals that big number plus, well, 1 squared is 1, so plus 1 equals, and I'm going to take the square root of that, square root of the answer, and I get 2.358, and I'm rounding here. I'm rounding to the nearest thousandth. Okay, so 2.358, and my YouTube window is closed. I wonder if any... Oh, isn't 2.135 negative? Yes, as a matter of fact, both of these are negative. Thank you for pointing that out. I knew that it would be useful to talk about something on YouTube, or sorry, to read my YouTube chat. Okay, so I've got both of these are negative, yeah, but when they become positive here. Now, keep in mind when we calculate the length of the hypotenuse, we are just oh, okay. Looks like there's some stuff going on in the chat. Okay. Anyway, yeah. So the length of the hypotenuse is just going to be positive. That's always going to be a positive length. So I'll just write 2.358. There we go. And there you have it. So there is our hypotenuse. So let's go ahead and write this down. That's going to be 2.358. And now we can calculate that ratio properly. So that ratio should be 2.135 divided by 2.358 equals 0.905. Okay, so 0.905. Okay. Yeah, let's try to keep the chat, you know, school appropriate. Like, this is a classroom, right? Okay. So let's see here. We're gonna solve these problems. Okay, that's good. Okay, I think we're good with one more question, and then we'll, you know, why don't we actually use this one as the exit slip? Okay. We're going to use this one as the exit slip. So let's see here. Okay. Okay, so for the exit slip, we are going to do, so if theta is in standard position, so that means it's in quadrant 1. Okay. If it's in standard position, and then I want you to find sine of theta. Okay, so so find sine of theta if the terminal side ends on the point. Let's do root 2, root 7. Root 2, root 7. Okay? So if that is the terminal point, so basically we're in standard position, so this is our angle right here. We're in the first quadrant, and this point right here is the point root 2, root 7. I want you to find sine of theta. Okay? I want you to find sine of theta. So give that a shot. And you can submit your answer in the exit slip. If you can't do it, if it's just like, no, I'm not able to do that, I can't solve it, then let me know. Just say was not able to complete the exit slip or something like that. So why don't we use, we should have, absolutely, because this should be negative 2.135. Thank you for pointing that out. I'm a little scatterbrained today. I'm not sure what's wrong with me. So this whole thing should have been negative, right? Because we are in the third quadrant, and in the third quadrant, the only trig ratio that's positive is tan. Everything else is negative. So sine of beta should be negative in this case, and that's because this 2.135 is not 2.135, it's negative 2.135. So yeah, I think I made a mistake for every single example that I did. So that goes to show sometimes it doesn't matter how many years you spend doing this stuff. You can still make mistakes. Okay. So so thanks for pointing out my little errors. You guys are very keen. I'm glad I like it. I'm very happy when I'm corrected, because it tells me that you're following along, you're paying attention to that sort of thing. So anyway, there's your exit slip. Let me know if you are struggling with it. I've had a couple of messages about the final project and what that could look like. I'll maybe start talking about that later this week, so probably tomorrow or on Friday. I'll reserve a little bit of time in class to talk about the project and maybe give you some ideas, some starting points. So if you do want to do that, then you can maybe get started on it now. So the project, I don't want the project to be like this big thing, but work is much easier when you spread it out, right? So if you wanted to start maybe thinking about which topics you want to explore for your project, now would be a good time to do that. So later this week, I'll give you maybe a little more information about the project and maybe some more guidelines. And if people really would like, I would be willing to put together like a little guiding document to help you out with the project. Can you make something on Desmos? Absolutely, yeah. Like Desmos would be an incredible resource for making a project. So if you wanted to make some kind of cool graph that shows some of the graphs that we've learned throughout the year, and if you had little sliders and little things, like there's so many cool things you can do on Desmos. So Desmos would absolutely be an incredible medium to make a math project. So that would be one thing you could do. So I'll talk a little bit about some of the projects that you can do. I realized I actually did do this last year with another class where I had students do a project instead of a final test. And I think I mentioned that maybe I was a little hesitant about projects because they tend to blow up. Usually what happens in my experience is that everyone wants to do a project because it sounds so cool, but then there's the procrastinating, and then all of a sudden it's like the day before the test, and it's like, oh, I haven't studied for the test because I was planning on doing the project, but I procrastinated and didn't do the project, so you kind of run into that sort of problem. So I think that if we started doing some stuff with the project now, just to get the ball rolling, I think that would be a good idea. I was also thinking that I should really do like a sign up. Like we should actually put on paper like who's doing what. I think it's really important to do that. And as well with the project, I think that if you do want to do a project, you should have some idea of what the project could look like at some point soon. So I'll talk more about the project maybe either tomorrow or on Friday. As you know, I'm very forgetful, and I apologize for my forgetfulness. So if I do end up just blabbering all class and then about to close down the stream, just shout at me, just say, hey, what about the project? And I will prepare something. Sometimes I forget. I'm in the. It's weird being on camera live on the internet all day. It kind of my memory and my perception of time, everything seems weird right now. So if I seem a little more forgetful, I mean you just saw my lecture. I made a mistake on every single question that I did, so I'm a little spaced out. And I think that's just from sitting on this desk all day, every day, broadcasting myself live on the internet, takes a toll on you. So we're not going to do this forever, right? So it's not like I'm going to go crazy or something. But what I'm trying to say is that I am a little more forgetful than I usually am. So if I do forget to talk about the project by Friday at the end of class, then just shout at me and just say, hey, Mr. Bennett, what about that project? Okay, now I'm blabbering and I'm eating it into your morning. So go have a good day. I will post a little bit of homework on the stuff on the website shortly. But this homework I'd like us to do throughout the rest of the week. So don't feel like you need to finish it right this minute. But if you do want to get started on it today, then you can go ahead and do that. Otherwise, I'll talk more about the homework tomorrow. Okay, bye-bye, guys. Have a good one.